Hello there and welcome to this new video, and in this video we will going to do the statistical data exploration within the Tableau. So Tableau is very helpful in doing the data exploration, as you would probably know if you are watching my previous videos, and we have created several charts and graphics for the data exploration as well as the projects into the Tableau. And today I will show you the statistical data exploration based on the data set on which I created a video, the last video, which was a movie data set dashboard. If you have not watched that video, I highly recommend that you watch that video. As well as in this I will be straight away going into the methodologies about how to understand the question and how to answer it, not pretty much into step-by-step tutorial or something, but a high level, quickly moving into the exploration side. So idea is to focus more on the implementation side. So let's go ahead and see the questions. So I have 10 questions that we will be exploring, and these are all related to the normal data analysis scenarios or the interview scenarios. So keep watching these so that you're not missing any of this thing and having more outcome when you are doing any real-time analysis or the interview, answering the interview questions. So let's move on without any much further talking, directly dive into the questions of our interest. So the first question is there any relationship between movie budget and revenue? So as I said, the dataset that I am using is basically the movie dataset, and it has two variables. What is the movie budget? So it has a budget variable and the gross revenue. So if I just go here and show you this dataset, here is our budget, if you can see this, right? And if I go on the left side, here is our revenue. So gross is nothing but the gross revenue. So if I go back to this presentation, we want to understand if there is any relationship between the budget and revenue. So the hypothesis is higher the budget, higher the revenue, or we are wrong in that case. So let's go ahead and see how we can implement it in Tableau and the problems that may come when we are seeing the data at the very first time. So for that, I'll come over here in this Tableau sheet. I'll come to text file because it is a CSV file, and the data set is the movies data set. And over here I have the same data set selected here and their respective columns and the data values, which is color, director names, so on and so forth. If you see, the gross column is over here. The genre is basically the different genre like action, adventure, fantasy, sci-fi and all. So what we can do, as you can see, it is having the separator, which is a pipe separator. So what you can do is come over here and click on split. It will split the first three, the action, adventure and fantasy, by looking at the data that based on the relevancy, that it sees that maximum 3 categories which is present most on an average into all the different values, which is around 5,000 values. But if you have the requirement where you want each and every value, you can go to the custom split. So once you have this data set, you can further fine tune it. So for example, I can clearly see that there are some null. So what I want is probably, I don't want any row where the gross is null. So what I can do is come over here, add on the filters, click over add, and over here I will see the gross. So I can even search. As you can see, I just entered a couple of words and gross is over there, and I can just say at least 162. That means this is the minimum. So I'll just click OK, and all those rows which will be having the null value, so anything below 162 was not there, so that means it is a null. So all the null values have been removed, especially in scenarios where you have the gross revenue. It may happen that there are furthermore null values. So for example, there may be scenarios where actor 3 is missing, or sorry, the actor 2 is missing, or actor 1 is missing, or maybe director name is missing, or the color is missing. That's a separate scenarios that one may need to address. But what you can do is simply keep on coming over here based on the needs and keep removing the null values as and when you see it is not making the contribution into the analysis. But for now, I'll just go to the sheet 1, and in the sheet 1, the question of our interest is there any relationship between movie budget and revenue? So movie budget, all right, so here is this budget, and the revenue is the gross revenue. And if I come over here to understand the relationship, by default we have the scatter plot. But the problem is, once we plot the data, we get only one data point, and it's because it has aggregated all the data points. So you can come over in analysis, uncheck the aggregate measure, and now you have all the measure. Now another problem is that I can't really understand this data. Reason being is, most of these data points are laying over here, that means pretty much on the ground, whereas some of the data points which I can see as an outliers. So for example, this budget of the movie is around 12 billion. I'm not sure if it is really true or if it is a mistake that somebody who was typing in the value have done that, but seems like another outlier is 4.2 billion and 2.4 billion. If you want to further drill down about what it is or which movie it is, what you can do is simply come over here and look at the movie title and put it on the detail. Once you put the movie title on detail, you have the movie title appearing over here, which you can see is the host. So as a data analyst, what you can do is you can look for this particular row in the real data set or check with the SMEs, the subject matter experts, and they will confirm whether this is really right or not. Similarly, in case of Lady Vengeance or in the Princess Mononoke and Steam Boy and all of that. So once you have this, how you can make sense out of it? So to do that, what I suggest is that, for example, this budget. So in case of a budget, I want to remove the outlier. So show filter. What I want is, I want to explore the values which are under 500, under the budget of 500 million. So we are having like 529, and if I further come down, you will see that data points start making some sense. So over here, 280 million. So this is one way. So 1100 million is something the highest budget is, and it is for the movie Akira, and you can see the values have started showing you the information. If you further come down to around this is 367 million if I'm not wrong, and you can clearly see the relationship. So as a data analyst, you need to explore the data like this, where you are playing with the filters or with the movie titles just to make sure that whatever data points you are having is correct enough. But here in scenarios like this, it shows that for most of the observation, it shows that it is a anything which is like less than 1 billion, it shows that there is a positive correlation. So as you go down, the higher the budget, the better the gross revenue is. So probably you can create a sort of a categories like 0 to 100 million, 100 to 200 million, or maybe 0 to 100, 100 to 500, and 500 to 1 billion, and see what are the output that is coming. So that is one thing to understand the relationship. So over here, you can see that there is a positive correlation when the budget limit is 735 million. And as I said, you can create categories and make more sense out of it. All right, I'll create a new sheet, go back to the statistical data exploration presentation, and identify the next question, which is what are the duration outliers in the various genre of movies. Duration outliers in various genre of movies. All right, so what do we have is basically the main genre, which is this, and the duration is over here, and the question is what are the duration outliers. So to understand the outliers, what we can do is create the box and whisker plot which summarizes the data. So right now it has summarized all the data points, but what I want is uncheck the aggregate measure, come over here, and genre split over here, and now I have all the different genres and their respective outliers. And in some of the outliers, for example, the drama feels like it has most of the outliers, whereas when it comes to adventure, biography, and the crime has the most significant outliers over there when it comes to the duration. And most consistent is the family movie genre. If you can see, almost there is like no outliers, so there is no outliers, followed by musical genre movies and sci-fi movies, which is a little surprising, but yeah, that's what the data is revealing. And same is the case of Western, which is one of the genre, and animation, which is which are like pretty consistent in nature. So this will help you understand where the variation in the data is a lot of variation, and what are the outliers that are present, right? So let's move on to the third question. What is the distribution of various movie duration? All right. So the duration is this, and to identify the distribution, we create the box plot chart. So that can be an interview question, that what chart you will use when you identify the distribution of movie duration or any other variable of interest. So in this case, we can clearly see that it sort of follows the standard normal distribution, if you can see, and slightly tilted or skewed towards the right side. But one can clearly see is that 100 minutes movie is basically the one where or the 94 minutes movie is the duration bin is basically 94. So it's basically the bin in which the maximum amount of movies or maximum number of movies which are being created, because on the x-axis you have duration bins, and here it is basically the count of movies. All right, so let's move on to the next one. And what do we have is, does having more Facebook likes have an impact on revenue? Okay, well, again, it's a relationship question, right? So revenue is over here, Facebook likes, movie Facebook likes. Now you have movie Facebook like, actor Facebook like, director Facebook like, but in this case it is, what we want is the movie Facebook likes. And come over here, create a scatter chart, uncheck the aggregate measures, and what data clearly reveals that having the more Facebook likes result into the gross revenue. So it seems like the 45-degree angle line over here, as you can see from the data, which may fit it very perfectly, just to minimize the errors, and shows that clearly upward trend. So yes, there is a positive relationship when in the gross revenue. So that means the more the gross revenue if the movie is having more Facebook likes. All right, so let's move on to the next question. Is there any relationship between Facebook likes and Imdb voting? Okay, so I'll create one more sheet. Imdb score or Imdb voting and the movie Facebook likes, right? Interest of the chart is again the scatter chart, just to understand the relationship. So by now, whenever you will see a question which is related to the relationship of two variables, you know what the answer is. You will going to answer in the interview or anywhere it's been asked, or if there is a question in front of you in the analysis. So this shows that sort of positive correlation, but if I just flip it from a different point of view, up until like 5 Imdb score, there is nothing. But as soon as the score is going above 5, there is some positive correlation which is present. It can be positive, not the linear, what I say, it's like the polynomial line, which I believe, the curve line, which it will fit it better. So yes, one can say that when the IMDb score is going higher than 5, there is a relationship between the movie Facebook likes and the IMDb scores. That means the people over there at two different locations are rating the movie with the similar score. So let's move on, and next question, correlation matrix between various numerical data points. All right, so let me come over here, and creating a correlation matrix is very simple. The final visual may look a bit daunting for any new user or a bit complex, but creation is very simple within Tableau. So what we have so far discussed is basically the budget, right? Let's say budget and duration, whether it has any correlation. So I'll go over here in analysis and uncheck this aggregated marks, right? Now what I'll do is I will have gross over there. So I have another variable there and gross over here, right? Similarly, I will keep on adding the variable based on what are all the things which we want as in a correlation matrix. So budget again over here, and duration is over there, and then IMDb score, right? And IMDb score, correct? And Facebook likes. This is what we have been exploring so far, and Facebook likes again over here. So now what I have just gone, and I'll just create the entire view. Yeah, so what we have just created is the correlation matrix, which you will find it in the Python or in the R, which basically seeks the correlation. So for example, between duration and budget. So correlation is over here, duration and gross revenue. Duration and duration, it has to be a positive upward linear correlation, and then duration and IMDb score if there is any correlation, and duration and the Facebook likes. Similarly for each of the variables, based on what is your interest and based on your needs, you can keep on adding the variable over here. And as you can see, in like few seconds, we have a lot of information which probably you will interpret in a couple of hours to basically make sense out of it. But what I wanted to show you is how you can create this correlation matrix over here. All right, next let's move on to the next one, which is the genre budget changing as the time is changing? Okay, so genre for the budget, or the budget for the genre, is changing as the time is changing. All right, let's move on to this next sheet. So what do we have is basically budget and time first of all, and genre is the variable of another interest. So title year, and the budget is over here. If I go and create the, so this is not present. I was hoping to get the bar chart for this, but what I can do is I can first take genre, I can take budget, and this is this. All right, and now what I can do is I can have the title year over here, and I can bring the genre over here, and from here I can change it to bar. Doesn't look like a very good chart. I can't make anything out of it. So what I'll do is first of all, let me just remove everything and show you from the scratch. And the problem which I see is mainly because it is a numerical variable that it has considered, or the Tableau has considered. So what I'll do is I will change the data type to date, and now let me create the chart with the title and year, and yeah, I can see the bar chart now. And I will flip this like this, and if you see, the budget is started appearing from here to here. So what I'll do is I'll just sort it or sort ascending order, right? And now I will take the genre to basically understand. Genre is over here on the color. I'll just remove this, hide the card. So this is again a lot of problems with the categories because the number of categories are high. So what I'll do is I will change this to the genre split 1, which will give us a better idea. So yeah, this is something more meaningful for us, which I can read, and clearly you can see that there is some increment or there is some constant increment into the action movies, but something has happened in the 2006 where the comedy has got the maximum budget. The movies in the comedy has got the maximum budget. Probably in that year maximum number of comedy movies have come. So that's why it is showing you a clear shift over here. Similarly, the movies which is related to the adventure, the budget is going down, as you can see, compared to in 1997 that was like 2.6 billion, 2.6 billion, and in where I am over here is the 2006 is 1 billion, and then we can look at the different years to basically understand how it is going. But from the chart it looks like the trend is going down. However, if I see the trend is sorted by the values, what I can do is I can sort it using the numbers. So numbers are coming in a proper order. So you can sort it by either by values or by these this number of years and get the relevant output. Alright, so let's move on and see the next question. What is the distribution of IMDb ratings among various genre? So for that, what I'll do is, let me close this. So let me create a new sheet. So first of all, the distribution of IMDb score, and here is our distribution, sort of left skewed if you see, whereas if you can see 6.3 bin is basically the highest one. And to understand the genres rating, what you can do is come over here and pick the color over there, and clearly, you know, the comedy is getting most of the average rating, which is like 6.3, followed by the action, and in the higher segment the comedy is going down and it is more given to the action movies. So sort of action is leading the pack when it comes to having the higher rating, followed by the drama movies. So like drama is also getting a lot of traction. Then the crime. So crime, drama, and action, very less to comedy. Alright, so this is how you can basically make some sense out of the data from the distribution perspective. So you have the ratings distribution, and in that you have brought in the genre to basically understand how the ratings are distributed by various genre. Not only this, let's say cancel this. So what? Not only this, if I just remove that, and if I want to clearly understand, I can come over here and click on show filter, and I can simply say action, or I can see adventure, I can see animation, I can see biography or comedy, which is another straightforward feature to understand category by category. All right, let's move on. See the another thing in action. All right. So the next one is, what is the most revenue fetching category for a movie? So revenue fetching category, which is basically a category rating, what I meant when I was writing this question, and then the revenue is basically the gross revenue. Okay, so let me come over here, and over here what I have is basically the content rating over here, and the revenue, the gross. If I just come over here and click on the bar chart, so this bar chart basically shows, if I just sort it, the PG-13 is clearly the winner, followed by the rating R, the PG, the G rating, and then a couple of other categories which having a very low data point. So this can be one of the ways, but not very intuitive and very informational. It will be pretty amazing to see the change over a period of time. So what I can take is basically the title year, and if I just put it over there and take the content rating on this particular chart and change it to a bar, and now you see it shows a pretty amazing chart which depicts how the gross revenue is changing across various categories. Definitely PAC is leading by the PG-13, but you can see a good variation among the various years for the category R, as well as this category, which is the GP category, is pretty much there, and the rating or the average is increasing, the decreasing. So this for me, this chart makes more sense than the one which I previously created, but again, at the end of the day, it should serve the purpose that you want to get it out from the analysis. So let's create a new sheet and move on to the last question, which is Facebook rating relationships with movie ratings. So Facebook ratings is basically nothing but the movie Facebook likes over here, and the rating is basically the IMDb score. I'm not sure if I covered it. So let me create a chart over here, and to understand the relationship, uncheck the aggregate measure. Looks like I created this chart, but no harm in creating it again. I remember we switched it like this, and above the movie score 5 we are seeing the positively trend relationship. But that's not the end of the analysis. I mean, this is just, we have scratched the surface with these 10 questions which I could frame by looking at the data. What are the questions that is coming in your mind when you look at the data? What sort of analysis you would like to do when you want to deep dive into the data, or some predictive analytics that you would like to do? Because this data set is basically a predictive analytics data set. You can do the supervised, unsupervised, forecasting, prediction, all of those different things on this data set, and basically get the results out. However, the number of rows is pretty small, like 5,000, just because it is for the demonstration purpose. But you can scrape the IMDb data set and get like even millions of rows from there. So that is what I wanted to mainly discuss. Let me know how much you liked it, or what sort of things you would like to see in my future videos, and I'll try to cater those in my future videos. And yeah, thank you so much. Share it with your friends and colleagues.